Page 11. Two more products of radicals. The nth root of a times b is the nth root of a times the nth root of b. For example, you've seen this with square roots. Remember, if there's no number written in there, it's an implied 2. You don't need the 2. If you put it in, that's fine. You'll never see it there unless you want to write it. The square root of 45. 45 is 9 times 5, and we know the square root of 9 is 3. So that applies for any nth power, like 12 times 18. They have the same index there. Those are both 3's. So I can multiply 12 times 18. That's 216. I didn't do it out here, but that's not so bad. Oh, do I have to multiply 12 times 18? What's 8 times 2? 16. 1 times 8 is 8, plus 1 is 9. Throw in your 0, add 120. And 96. 6 and 0 is 6. 9 and 2 is 11. 1 and 1 is 2. 216. Is 6 to the third power. Try to remember that one. 6 to the third power is 216. So the cube root of 216 is 6. Then if you have the nth root of a fraction, you can apply that nth root to both the numerator and denominator separately. For example, the cube root of 8 over 27 is the cube root of 8, or 2, over the cube root of 27, or 3. It goes the other way too. Right? If you have the same index to both the numerator and denominator, you can put those together. And I know 80 over 5 is 16. If you don't know, you can always move to long division. 5 goes into 8 once. Multiply 1 times 5 and subtract. Bring down the 0. 5 goes into 36 times, and the fourth root of 16 is 2, because 2 to the fourth is 16, right? 2 times 2 times 2 times 2 is 4 times 4 is 16. Okay. 2 examples there, 2 more here. Same cube root, same index. So 32 over 4 simplifies to 8. You should definitely know by now 2 to the third power is 8, so the cube root of 8 is 2. Here we have different indexes, curveball, but hopefully you can think of those. 3 to the fourth power is 3 times 3 times 3 times 3 is 9 times 9 is 81. So the fourth root of 81 is 3. The cube root of 27 is also 3. So that fraction, it turns out, is the equivalent of 1. Little curveball there. Here's our reminder about rationalizing the denominator. There's a denominator with a square root of 2. So I multiply the numerator and denominator by the same irrational denominator, because that's the equivalent of 1. Anything times 1 is the same thing. So I haven't changed the number, but radical 2 times radical 2 is radical 4, which I know is 2. So that's rational, where this is irrational. All right, so 3 radical 2 over 2 is the equivalent of 3 over radical 2. Those are equivalent. Now, if we have the radical 5, let's multiply the numerator and denominator by radical 5, since that gets us to the square root of 25, or 5. In the numerator, radical 3 times radical 5 is radical 15. So 6 radical 15, and there's page 11.